Electrolysis of salt solutions. This experiment will show the breakdown of ionic salt solutions using an electric current. Observations will help us determine the elements formed after each electrolysis. You will be provided with the following equipment: a power supply, crocodile clips and leads, 2 carbon electrodes, a 100 centimeter cubed beaker, and something to hold the electrodes in place. 4 different salt solutions: copper chloride, copper sulfate, sodium chloride, and sodium sulfate. Finally, emery paper, tweezers, and blue litmus paper. Pour your first salt solution of copper chloride into the 100 centimeter cubed beaker until it is half filled. Use the equipment provided to suspend the carbon electrodes into your solution. You must make sure that the carbon rods are not touching each other and that they are both partially submerged in the liquid. Next, you need to connect the electrodes to the power supply with the crocodile leads provided. The DC terminals are used. That's the red and the black coloured plug-ins on the power pack. The carbon electrode connected to the black terminal is the cathode. It is supplied with electrons and so is negatively charged. The electrode connected to the red terminal is the anode. Here, the electrons are removed from the ionic solution. The electrode on the left of the screen is the negative cathode, and on the right is the positive anode. When you have set up the crocodile clips correctly, make sure the power supply is set to 4 volts. Chlorine gas is produced during this experiment. This is toxic, and so for safety reasons you will need to make sure you are working in a well-ventilated room and that you do not have the power pack switched on for more than 5 minutes for each salt solution. Switch on the power supply and look at both electrodes in turn. First, let's focus on the anode, the positive electrode on the right-hand side of the screen. Bubbles are seen, indicating the production of a gas. To test this gas, use the blue litmus paper. With tweezers, hold the end of the litmus and dip it into the solution next to the anode. Note that litmus paper bleaches white in the presence of chlorine, but remains blue in the presence of oxygen. Record your observations in the table provided. Next, examine the cathode, the negative electrode on the left-hand side of the screen. If there is evidence of a pinkish metal deposit, then this indicates the formation of copper. Again, record your results in the table. Switch off the power pack and disconnect the crocodile clips from the electrodes. Clean the equipment carefully. Discard the salt solution and rinse the beaker out with water. Use emery paper to remove metal deposits off the electrode. Get your next salt solution ready, in this case, copper sulfate. Attach the electrodes to the power supply in the same way as before. Remember, the electrode connected to the black terminal will be the cathode, and the red terminal will be the anode. Turn on the power supply and observe the electrodes. Here, you can see bubbles at the anode. When testing with litmus, it does not bleach white this time, but it remains blue. A pinkish metal deposit has also formed on the cathode. Fill in the table with your observations. After switching off and cleaning your equipment again, repeat the setup with sodium chloride. Bubbles are produced at both electrodes here. The blue litmus paper bleaches white when dipped into the solution next to the anode, and this time there is no metal deposit on the cathode, but a gas has been produced. This must be hydrogen. Again, complete the table provided with your observations. Finally, observe the last salt solution of sodium sulfate. Bubbles are produced at both electrodes again. When testing the anode with litmus paper, the paper remains blue. There is also gas produced at the cathode, and no metal deposit seen. Complete the table with observations from your last salt solution. To finish, make sure you switch off the power supply, disconnect the circuit, and ensure that all equipment is cleaned.